Hi, I'm Ms. Cho, and in this video, we'll do polynomial synthetic division. Synthetic division is a shortcut method of dividing polynomials by linear factors. And what I mean by linear factors is that your divisor has to be x plus something or x minus something. Your highest exponent of your x's has to be 1. If it's anything greater than 1, you cannot do synthetic division. You have to do long division. As you can see in long division, it's long, and so the synthetic division is a way of dividing by just not dealing with the variables and looking just at the numbers in all of this. If you need a refresher on long division, you can see my other video where we actually did this problem. Let's take a look at an example. Here we're being asked to use synthetic division to find a quotient and remainder of 3x minus 7x cubed plus 5 divided by x plus 2. Before we start, I have to ask myself 3 questions. The first is my divisor linear? So my divisor is my x plus 2. Is my highest exponent of x 1? Yes, so that's good. We can move on. My second question is my dividend in standard form? And by standard form, I mean, are the terms arranged from highest exponent to lowest exponent? I see a cube term here, and this is x to the first term. So it is not in order. The cube needs to be first, and then I'm going to go down. And so my next exponent is going to be the x to the first power, and then my constant term. All right, so now that it's in standard form, I have to ask myself, are all the exponents there? If I start at 3, do I also have an x squared and an x term? And I'm actually missing my x squared term, so I have to give a placeholder with a 0. And the reason for this is because it's like in numbers, when you say 1002, you can't just write 1002 because what you really mean is that I have 1,000, 0 hundreds, 0 tens, and 2 ones. And so in the same way, we have to add our 0 back in to make sure that everything's in its right place. Now that I have checked that all 3 things are okay, we can move on. I'm going to rewrite my dividend in standard form so that I have it for reference. And the first thing we're going to do is going to write the 0 of the divisor and the coefficients of the polynomial. So the 0 of the divisor is what value makes x plus 2 equal to 0. So I set it equal to 0 and I solve for x. If I take 2 from both sides, I find that x is equal to negative 2. So the 0 of my divisor is negative 2. And then I'm going to write all the coefficients, just the numbers, in order. So negative 7, 0, 3, and 5. And I'm actually going to write their places, the exponents, just to remind myself. This is optional, you don't have to do it, but I find that it helps keep me organized. And once you've written all of that, you're going to draw an L to divide the two, and you're going to leave space for a row underneath your coefficients. So that's step 1. In step 2, you're going to drop the first coefficient down, straight down to the bottom below the line. That's easy. And then in step 3, you're going to multiply your 0 of your divisor times whatever's in the bottom row. So negative 2 times negative 7 is going to be positive 14, and I bring it over to the next column. That's step 3. In my 4th step, I'm going to add down the column. So 0 plus 14 is positive 14. And then I repeat steps 3 and 4 until I reach the end. So again, negative 2 times 14 is negative 28. I'm going to add down the column, and that gives me negative 25. And then I'm going to multiply again. Negative 2 times negative 25 is positive 50. I'm going to add down the column, and that gives me 55. And this is my last one, so I'm just going to draw a box around it. This is going to be my remainder. Once I've hit the end, I'm going to rewrite my answer with variables. And so I'm just going to recopy down the coefficients, negative 7, 14, negative 25. And since I know my 55 is a remainder, I'm just going to go ahead and write it over my divisor, which was x plus 2. My exponents and the variables, this is going to be 7x. And how do I know what exponent goes with it? It's going to be 1 less than my starting exponent. So since I started with a cube, this is going to be 7x squared. Once I have that first exponent, I can make my way down. So x the first, and then I have no more x's. So this is just a constant minus 25. Let's compare this with long division. So you can see that if I use long division, I get the same answer. It's negative 7x squared plus 14x minus 25 plus 55 over x plus 2. So some things to compare and contrast with both forms. You're going to need the standard form with all your exponents accounted for and a 0 placeholders as needed. In long division, your divisor is going to be your whole factor, and in synthetic division, you're going to use the 0 of this factor. So you're going to set the divisor equal to 0 and solve for x. In long division, your quotient is on the top, and in synthetic division, it's on the bottom. But I also want you to pay attention to the numbers. The 0, 14, 14, it's all right here in the long division. This 3, negative 28, negative 25 is right here in this step. And this 5, 50, 55 is right here in this step. So synthetic division is just a way to do the same thing, but without having to write out all your variables in every step. Let's summarize. Before you even start polynomial synthetic division, you have to ask yourself 3 questions. Is your divisor linear? Are you dividing by x plus or x minus a number? The second question is your dividend in standard form? Is it written with the highest exponent first and counting downwards? And your third question is, are all your exponents there? If they're not there, you have to write in zeros just as placeholders. So once you have all that sorted out, you find the 0 of your divisor, and you're going to write that next to your coefficients. And then you bring down that first coefficient, and then you multiply and add over and over. So you multiply the 0 of your divisor times whatever's in the bottom row, and then you carry it over to the next term. You multiply, and then you bring it over and add down. You multiply, bring it over, add down until you get to the end. Once you're at the end, then you rewrite your answer with variables, making sure that your starting exponent is 1 less than whatever you had at the beginning.